Okay, picture the scene. It's a Tuesday morning. It's always a Tuesday, isn't it?
Always Tuesday.
You're the facility manager at a mid-sized distribution center. You're standing on the concrete floor. You've probably got a lukewarm coffee in your hand, and you're just staring out at the racking.
Hmm.
And you have this sinking feeling in your stomach because the racks are full. The aisles are cluttered. People are squeezing past pallets that don't have a home.
And you know there's more coming.
You know for a fact that a container of new inventory is hitting the loading dock on Friday.
That is the absolute nightmare scenario. It's that classic walls are closing in moment. We see this all the time in logistics.
Exactly. And in that moment, your brain gives you two very expensive, very painful solutions. Option A, lease a new, bigger
A
building,
move.
which means logistics, changing your address, doubling your rent probably.
Yeah.
Or option B, build an extension, which is permits, contractors, concrete, dust everywhere for months.
Both of those are what we call horizontal solutions. They assume the only way to get more space is to sprawl outward. But the sources we're looking at today, specifically insights from the team at Vertical Storage USA, they suggest that that instinct to sprawl is actually, well, it's wrong. The solution isn't about looking out, it's about looking up.
Welcome back to the Deep Dive. Today, we are unpacking the world of high-density storage. We're going to figure out how to reclaim the air in your warehouse by focusing on a piece of technology called the Vertical Lift Module, or VLM. We're drawing our data and our technical specs today from the experts at Vertical Storage USA, which is powered by Outsource Equipment Company. These are the folks behind the Elevate series, the Core, the Pro, and the Elite.
And I want to be clear right off the bat, this isn't just about buying taller shelves. This is a fundamental shift in how we think about cubic volume. We're going to break down the mechanics, how these machines actually work, and then look hard at the economics.
Yeah.
Because there's a really interesting argument here that spending 50 or 100 grand on a robot might actually be the cheap option.
That's the part I really want to get to, the money. Because whenever I hear automation, my brain just hears expensive.
Sure.
But let's start with the hardware. When I first saw the term vertical lift module, I admit I just pictured a really, really tall bookshelf with a rolling ladder. But looking at the breakdown, that is wildly inaccurate.
It is. Comparing a VLM to a bookshelf is like comparing a Tesla to a horse and buggy. I mean, they both get you from A to B,
Yeah.
but the mechanism, the efficiency, it's a different world.
So what is it then?
A VLM is officially classified as an ASRS.
ASRS. Okay, let's decode that before we go any further.
Automated Storage and Retrieval System. It essentially means the system does the fetching for you.
Okay.
So physically, I want you to picture a giant enclosed steel tower, could be 20, 30, even 40 feet tall, reaching right up to your ceiling.
Right up to the rafters.
Exactly. Inside that tower, running up the front and the back, you have hundreds of metal trays. And right down the center, in that empty shaft, there's a robotic extractor.
A robotic extractor, like an elevator car.
Sort of, but smarter. It moves vertically, finds the exact tray you need, pulls it into the center, and then delivers it down to an access window at waist height where the operator is standing.
So if I need part X, I don't walk to aisle 4, base 6, shelf 2. I just type part X into a keypad, and the machine brings it to me.
Precisely. This is the core philosophy. Goods to person.
Goods to person.
In a traditional setup, you are paying people to walk. They walk to the shelf, they search for the item, they walk back. That's person to goods. A VLM flips that entirely. The person stands still, the inventory comes to them.
Now here's where I want to push on the efficiency claim. Because if I have a tall shelf and I put a small box of screws on it, I'm wasting all the space above that box. How does a VLM solve that? Is it just fixed slots?
That is the killer feature. No, it's not fixed at all. This is what the sources call dynamic storage, and it's arguably the most important technical detail.
Okay.
When you put a tray of items back into the machine, the system actually scans the height of the items on that tray.
Wait, it measures the product every single time?
Every single time. It uses a light curtain, usually. So if you put a hammer on a tray, the machine knows that tray is now exactly 4 inches tall. It then hunts for a slot inside the tower that's just barely over 4 inches, maybe 4.5, and slides it right in.
So it's basically playing Tetris with your inventory automatically.
That is the perfect analogy. It eliminates what we call dead air. With static shelving, you have to space your shelves for the tallest item you might store there.
Right.
Which means if you put something short next to it, you're just storing air. A VLM compresses all that air out. That's how they can claim to recover up to, say, 85 or 90% of your floor space.
That 90% number seems incredibly high. Is that a Best case scenario?
It's a pretty typical scenario when you're converting from static shelving. Think about it.
Yeah.
You're not just compressing the vertical space, you're also deleting the aisles.
The aisles, of course.
In a normal warehouse, you need an aisle between every single rack for a person or a forklift. With a VLM, the aisle is just that internal shaft where the robot moves. It's inches wide, not feet wide.
Okay, that tracks. You're trading horizontal walkways for a vertical shaft. Now, the source material also mentions industrial modular storage. That sounds a little like marketing speak to me.
It does, but it has a real meaning. It means flexibility.
How so?
Think about building a concrete mezzanine. That's permanent. Once it's in, good luck moving it. A VLM is modular. It's built in sections, almost like Lego blocks.
So if you move facilities,
You can disassemble it and take it with you. If you move to a building with a higher ceiling, you can often just add more modules to the top. It's not a sunk cost in the building. It's an asset you own and can move.
it's equipment, not real estate.
Exactly. It travels with the business.
Let's pivot to the alternatives. Because a VLM isn't the only game in town, the sources bring up vertical carousels. To the untrained eye, and frankly to me before I read this, they sound like the exact same thing.
This is a crucial distinction, and honestly, people buy the wrong one all the time because they don't get the mechanics. The difference is the movement. Think of a vertical carousel like a Ferris wheel.
A Ferris wheel. Okay, I'm picturing it.
All the shelves are linked together on a giant chain loop. If you want the shelf at the very top, you have to rotate the entire system, all the shelves, all that weight, until that specific shelf comes down to the bottom.
And a VLM is different how?
A VLM is an elevator. The trays sit still on the walls. They don't move unless they are called. The little extractor zips up, grabs one specific tray, and brings it down.
Why does that matter so much? Is one just better?
It comes down to physics and balance. Imagine your Ferris wheel again. What happens if you load heavy concrete blocks on one side and feathers on the other?
It's going to be unbalanced. The motor will struggle or it'll spin too fast.
Exactly. Carousels suffer from imbalance issues. You have to be really careful how you distribute the weight. VLMs don't care about balance at all because the extractor only ever lifts one tray at a time.
So the VLM is doing less work per cycle.
It's moving less mass. That makes VLMs much, much better for heavy loads. We're talking trays that can hold 1,000, maybe 2,000 pounds each. Carousels are typically for lighter, more uniform items, files, small pill bottles, that kind of thing. If you have heavy industrial parts, valves, dies, motors, you want a VLM.
Okay, so if I'm storing heavy, weirdly shaped aircraft parts, VLM is the winner. If I'm storing thousands of identical small vials, a carousel might work.
Right, but even then, the VLM usually wins on cube utilization because of that dynamic height adjustment we talked about. Carousels have fixed shelf heights. You can't change the spacing on a Ferris wheel seat on the fly.
Got it. So the VLM is the heavy-duty, smart option. Let's talk value. The sources break down the value proposition into 3 pillars: space, labor, and accuracy. We've hammered on space. Let's talk labor.
This is where the ROI usually comes from, honestly. In a manual warehouse, the most expensive thing you have isn't the inventory, it's the people walking around to find it.
The steps.
The steps. Studies show that pickers spend up to 60 or even 70% of their day just walking and searching.
70%. That is wildly inefficient. You're basically paying them to exercise.
It's standard. You're paying for a hike, not for picking. When you switch to a VLM, that walk time drops to near zero. The operator stands in one spot, the machine cycles, they pick, it cycles again. You can go from picking 50 lines an hour to 200 or 300.
So one person with a VLM can do the work of 4 people with push carts.
Often, yes. And they can do it without blowing out their back. That's the ergonomics piece.
Right. The sources mentioned the golden zone.
Exactly. The machine delivers every tray to waist height. No bending down to the bottom shelf, no climbing a rickety ladder to reach the top shelf. You reduce fatigue, but you also reduce the risk of injury. Workers' comp claims for back strains are a massive hidden cost.
Which brings us to pillar 3, accuracy.
Yeah.
Speed is great, but not if you're shipping the wrong stuff.
Yeah.
How does a VLM stop me from grabbing the wrong part?
Well, the machine presents the tray, but that tray might have 10 different compartments, so usually these systems integrate with pick-to-light technology.
How does that work?
Imagine a little laser pointer that shines directly on the specific compartment you need to pick from. Or maybe an LED strip lights up and says, take 3 from here.
So it takes the thinking out of it. You don't have to double-check the part number.
It removes the cognitive load. You just follow the light. The software tracks what you took. This brings picking accuracy up to 99.9%.
And there's a security angle here too, right? The sources mention it being lockable.
Think of it as a vault. If you have high-value items, expensive microchips, narcotics in a pharma setting, you can't leave those on an open shelf. A VLM is fully enclosed in steel. You can require a badge scan or a password just to operate it.
And the software logs everything.
Everything. User Steve accessed Tray 4 at 2:0 p.m. Total accountability. For industries like aerospace, that audit trail is mandatory.
Okay, let's get to the elephant in the room, the cost. I'm the facility manager. I'm sold on the idea, but now I have to go to the CFO and ask for a check. What's the deal?
It's a capital investment, no doubt. A new VLM, depending on the height and the capacity, is going to run you somewhere between $50,000 and maybe $150,000.
That's a significant chunk of change.
It is, but you have to look at the versus.
Yeah.
What's the cost of the alternative? If you don't buy the machine, you have to lease that new building. What's the cost of the extra rent over 5 years? What's the cost of the 3 extra employees you now need to hire?
The sources mention an ROI payback period. What are we looking at?
The data from Vertical Storage USA suggests a payback period of usually 12 to 24 months.
Wait, really? Under 2 years?
For industrial equipment, that is lightning fast. Usually you're looking at 5 years. But because the labor savings are so drastic and the space savings are so immediate, the math works out very quickly.
So after year 2, the machine is essentially printing money by saving you wages and rent.
That's the argument. It turns a variable cost, like labor, into a fixed asset that depreciates.
Now, for the smaller operations listening, maybe $100,000 is just not in the budget. The source material mentions Vertical Storage USA has an alternative strategy. They deal in used equipment.
This is a really interesting niche. Outsource Equipment Company, which powers them, specializes in pre-owned or remanufactured automation.
Is it safe to buy a used robot? That sounds kind of risky.
It's more like certified pre-owned.
Huh.
They take these machines, like a Modula MX50D or a Carousel, they inspect them, replace wear parts, update the software, and install them with a warranty.
What's the price difference we're talking about?
You can save significantly, maybe 30 to 50% off the sticker price of new, but there's another advantage that's even bigger than price right now. Lead time.
Supply chain.
Exactly. You order a brand new VLM from the factory, you might be waiting 20, 30 weeks for it to be built and shipped. A used machine is sitting in a warehouse in the USA right now. You could have it installed in a few weeks.
That's a huge factor if you're in that Tuesday crisis mode we talked about. You need space now, not in 6 months.
Right. It allows smaller players to get into the automation game without that massive barrier to entry. It kind of democratizes the tech a bit.
So we've gone from a panicked facility manager to a sophisticated automated operation. We've covered the tech, the labor, the money.
And we've solved the fundamental problem. We stopped treating the warehouse as a 2D map and started treating it as a 3D cube.
Before we wrap up, who is this actually for? Does a lumberyard need a VLM?
Probably not. Long, bulky items are tough for these machines. They really shine when you have a high SKU count. Lots of different items. And those items are small to medium-sized.
To auto parts.
Automotive is huge. Dealerships, manufacturing plants for tooling. E-commerce is massive, picking phone cases, chargers, beauty products, hospitals for surgical kits.
Basically, if you have thousands of little things and a high ceiling, you're the target market.
That's the rule of thumb. If you are storing air above your parts, you are a candidate.
It's fascinating how this tech changes the architecture of a business. It makes you realize how inefficiently we use space.
That's the final thought I'd leave you with. Real estate costs are only going one way, up. The air inside your building is an asset you are already paying for every month in rent or mortgage. You're paying for that empty space 20 feet off the ground.
And if you aren't using it, you're just throwing money into the atmosphere.
Exactly. The question isn't, do we have enough floor space? The question is, are we using the space we can't reach?
That is a great perspective shift. Stop looking at your feet and start looking up.
Maximize that vertical efficiency.
So here's my challenge to you, the listener. The next time you walk into your storage area, whether it's a massive DC, a parts room, or even just your own garage, look at the space above the top shelf. Look at that empty void. And imagine if you could access it as easily as opening a drawer. That is the promise of the VLM.
Work smarter, not harder.
Absolutely. That's it for this deep dive into the world of vertical storage. Thanks for climbing the ladder with us, or rather, taking the elevator. We'll catch you on the next one.